Is the function f of x equal absolute value of x differentiable at x equals 0? So what does differentiable mean? It means essentially is f prime of 0 exists. Okay, so all is asking is the limit exists. Is f prime of 0, which equals a limit as x approach 0, f of x minus f of 0 divided by x minus 0. Is this limit exists? Well, we take a look. Limit as x approach 0, absolute value of x divided by x. After we simplify, right? Because we get rid of the zeros. And you might say, well, can I bring the x inside the absolute value and cancel it and get 1? Not quite. Okay, you cannot just put a number inside a absolute value and expect nothing is changed for the quotient. So we have to have situation here. We have to think about what the absolute value do. Absolute value of x tells you that, okay, it's just x itself, it's the number itself. If the number is greater than or equal to 0, but it's going to be negative of that number if the number is less than 0. So think about absolute value of negative 2, right? It is 2, but what is 2? 2 is negative of negative 2. So this is how you can think about it. So we also need to have situation here. So we really need to look at the left limit and the right limit. Now this is the case. You have to look at left and right limit when you have piecewise function or absolute value function. Okay, whenever you have piecewise function, you have to break it into cases. If you have a polynomial, a radical function, a rational function, sine, cosine function, you don't have to break it into pieces because we know what to do with those functions. So for this one, what if x is approach 0 from the left? What it means? It means a little bit less than 0. So it means x approach 0 from the left is a negative number, right? So x is just x, but absolute value of a negative number is the opposite. Now you can do cancellation, and 1 is remain. Okay, so it's negative 1 divided by 1, you get negative 1. On the other hand, the right limit as x approach 0 from the right, a little bit more than 0, so the number is positive. You can just eliminate the absolute value. Well, when you do cancellation, you get 1 over 1, so equals 1. Now the left limit is negative 1 and the right limit is 1. The left limit does not equal the right limit, so the two-sided limit does not exist, okay, because of the left limit doesn't equal the right limit. It's an if and only if condition. Once they equal, then you will have a both-sided limit. So then, because the limit doesn't exist, because the answer to whether f prime of 0 exists, the answer is no, then this continuous function f of x equals absolute value of x is not differentiable at x equals 0. It also shows you that if a function is continuous, meaning you can draw it, you can draw the function without lifting your pen. Continuity does not imply differentiability. Okay, a continuous function is not necessarily differentiable at every point of its domain. However, a differentiable function implies is continuous. The function is continuous. And the proof is in our textbook. You're not required to memorize the proof, but you should have an idea of what implies what. Okay, we learn continuity first, and then we learn the differentiability. Okay, so differentiability will go back up. It will imply continuity. But continuity does not necessarily imply differentiability, which is demonstrated in this example.